doesn't matter, but it feels more logical to subtract the old one from the new one. Tja. I'll need a new name for this. What next? Okay, I don't get why the energy is this low. It should start at 50. Hmm? Now it's 50, and then we go down a little bit. And then only 10% of that should be subtracted from the 50. Yeah, no, I don't get it. Damn it. Oh, but I'm not found 50. Excellent. I'm pausing mocks. No, I'm pausing L mocks, I think. surely we would print that. X. Oh, I'm using the wrong range. What? No, I'm not. Well, actually, my memory says I used the wrong range. Isn't that like way small? Anyway, I should use the Y range. I think I used the X range. So, where is my kinetic energy? No, I'm using L max. That is the maximum of the Y range. That should be 50, I think. So let's print the actual value here in the constructor of the kinetic energy. XC tags, kinetic energy. The out entering constructor with the value LW. So then the maximum was set to LW. I'd already said it here. Initial height was set to. Okay, plop. Horrible. Well, it says 49.7, which is not 50, but pretty close to it. Initial height. Okay, the kinetic energy is being printed, so this is the value. I don't even need that one then. Might as well remove it again. Not printed. Undo, redo, ZZ, paste, update, new L. Hello, Kerem Khan. Ken, I mean. Kinetic energy. Oh, thanks. I can reuse that, right? To be the same output as here. I'm doing fine, but wondering why my kinetic energy is not 50, but like more 45. So it's set to 49, and then now it's being drawn at 45. What the hell? Oh yeah. We did travel 4? No, wait. What? Calculator. 38142. Yep. It doesn't make any sense. If we go from this to that value, it did subtract 4.5355, which is even larger than this. No way, that doesn't matter. Let's just set a breakpoint in there and all. It's just pure stupidity. You call me good, but it's 100% stupidity of me that it doesn't work at the moment. So I don't know. Still have to find that stupidity. Don't just step through the code and then I guess it will reveal itself. Okay, so the new LW is set to that, and what is then LW current? Oh! Oh, yeah, okay, that now it makes sense. It kind of assumes that you start here. So we go all the way down. By the time we end, yeah, it shouldn't matter where you start. If you start here or there or there or there or there. So if you start here, then it has to assume that we already traveled all the way from the top down to here as a first step. So it does subtract 10% of this height from the top to that point. That is then immediately, at the moment we are at the minimum, it's like 90% decreased already. And then another 90% when we reach the top. And I don't want that, so let's change friction. Friction. So I want that Oh boy. So I want that 1 minus friction squared is 0.9. Right, okay, so going from the top to the bottom, it drops 5%, and then if we go up again, then it drops another 5%. So by the time we get here, the maximum energy is at 45. Even though it went over it. Ejected because max is 46. Oh, the new one is 79 already. Yeah, that's definitely larger. The next one would be 43 because we make an enormous jump to begin with. This should be rejected. Oh, I agree with that. Why do we make such a huge jump? Because yeah, it gets steeper and steeper. That's why. Okay. Then I have to implement this point. Aborting. Aborting means that I want to stop going in the current direction, horizontally, that is. Yeah, how do I continue from here? I think I have to jump back to the best minimum and then go in the opposite direction. How am I doing that? Well, I think I have to jump back. I have to jump back actually without actually traveling. Jumping without traveling. It's a new hottest movie in the theaters. AKA June. Moving without traveling, wasn't it? Traveling without moving. That was it. Yeah, in this case, I don't want to lose any energy. I just want to pop up again at the minimum. How do we do that? Firstly, I have to find the best minimum. If there is one, there should be one. I think I store those things in extreme. Extremes. Next extreme. New extreme. Best minimum. The best minimum is the best guess as well. So if the best extreme equals the end, then we don't have a best minimum, and then we just give up completely. Okay, step 1, jump back. No. Jump to, well, it is back actually. Jump back to the best minimum. And continue in the opposite direction. Which means, I think, first of all, if there is no best minimum, no minimum was found at all. Dubious, but okay. Otherwise, change direction. Yeah, I'm not sure actually if the size of the W is to be taken equal. I need to set it to the opposite sign, but what step shall we take from here? I think just also a learning rate step or something like that. Kind of like this. Learning rate is also random actually, so we change the learning rate all the time. Dang, even that doesn't help. I need this, I think I need the scale. Would be a nice thing. Just begin with a step equal to the scale, but of that minimum. So then I have to store the scale at the moment that we store the extreme. Okay, so I do if delta is less than this, then we must set it to something positive. Do I have not a sign or something? Nope. Left, right, something. Left, right is a thing. each side. I think this is all we have. Int. It's not called the side though, just called direction. H direction. I have direction which is vertical, and now I need another direction which is horizontal. And then this becomes H direction times absolute value. Or not, but let's type that for now. So now I need to determine the absolute step size that I want to take. At least, is that what I want? Because is this even used? W delta. Current sample is added. Why would I do that? I just rejected a new sample. Ugh. Okay, samples rejected, so I have to do a lot of stuff, including making a new sample. Cannot just continue at the top. So this has to end with something like a new sample is, and then update of the kinetic energy. Step size. Yeah, okay, can I get the scale from my best minimum? What is best minimum? That's his list sample iterator, so that points to his sample. Yeah. You think I should store the scale here as well? No, well, not every symbol, just a minima. Let's not have a destructor at all. Then we get automatically a compile error. It tells me what constructor I need. I have something in my mouse buffer, I thought. Best minimum. Yeah, okay. So sample minimum. I should use that for the extremes. This is the extremes store a sample minimum. And I have no idea how many changes I made or what, but then I just switched to compile errors. But it looks very, not that serious. Insert, no matching member to call insert on. Okay, why not? Because this must also be sample minimum. How many other list samples do I have? That was the last one. And then we insert the current history, which is just a sample. So yeah, clearly I need to be able to construct what it is a sample. I'm not sure insert is constructing. Pretty sure it's not. Maybe it is. I don't know. So I make a sample minimum that would construct from a sample, then this might compile, but hey, we just need to pass the current scale as well. I think I'm just going to construct I don't think insert is going to request sample minimum, or would it? Let me try that first. So I just make a constructor which accepts a sample. Does it compile now? I did that before. Probably a few neurons in my head have died. Tertiary operator can no longer be used. Oh, that's not going to compile. Okay, yeah, Let's just not do this because I want to see if it compiles. Well, it does. So now I have somewhere an insert. Nobody knows where. So much new code. Too many changes already. I don't know. I don't like the number of changes. Just look for my insert. Ah, there, hidden one. So let's try to I don't think I have an insert in place or something like that. Or an in place that is an insert. Is it? Do we? No, we don't have that. I'm very sure, but not 100% sure. Shall we look it up? Type standard list. Standard list, so insert. There is an in place, but place returns an iterator. So this returns an iterator and it takes a pause. Is that very likely to the same as insert? Actually, it is. So insert just asks for a value, but you can also use in place for a list apparently. Well, then let's do that. In place, and now we can pass the constructors. I'm going to pass the sample first, and then I'm going to pass the scale. And then here, of course, the same thing. Surely this is the only place where that has happened. It's not even an insert left, so yes. Yep, which then means that my sample minimum now must be constructed from a sample and a scale. Which is not defined. Let's reference current scale. Let's move this down because scale is defined well here. And then, yeah, I don't know. Let's just make a copy. The scale at the moment the minimum was stored. Scale. Now we need an excess over that. Scale. 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 Well, first it should just compile again. And then Now I have the scale there. To having the scale, I can just set the step. Okay, let's say estimate. Set a new step size equal to the scale of this minimum. Double step is best minimum. Iterator accessor for the scale. Now I have a scale, not a step yet, so I'll need to get what of the scale? Scale, I need to get yeah, this value. Not even sure this is being used at all. I might as well. Ah, no, don't tell me. Really? No, wait a minute. I want to set the scale back to this scale, including the parabola or whatever. So, this is the step size, but no. No. Let's do it like this. Restore the scale of this minimum. Much better. Okay, so scale is a local, yeah, well, it's all, everything is local, but we have a variable in the scope called scale, probably, and I'm going to set that to the scale of that minimum. And then we set the new step size equal to the scale. Plop. The scale, this scale. Ta-da. So that then is a scale which automatically converts to double. Which then looks silly, because why would I suddenly call it step? Well, maybe I want to change it like the half of the scale first, or I don't know, learning rate times the scale. The scale is pretty big, yeah. You see, the thing is that I change the learning rate sometimes, while this thing here is really called 0.1. I want to keep that as well, then I reset it to this value. So here this changed, and it's kind of silly really, because I think the only reason I change it is because I'm lazy, and then later I pretend that, yeah, it's just, should not do this. This is a different story, however, so I'm still changing it, apparently. This is again silly, kind of abuse of learning rate. Here this is being used to keep going, it uses it. Let's call the learning rate current learning rate, and then I'll make a constant one as well. That's kind of nonsense as well. Maybe we should just start with the learning rate. It's probably learning rate anyway. Right, so then we have this is a constant now, and I want to have a non-constant current learning rate, which is set to the learning rate, and I don't think I need to define that there at all, like at all. Where am I using the learning rate for the first time? Not including comments. That is this scope, which means the while loop scope. Am I using it outside the while loop scope? Nope. So I probably should just set it somewhere here. Now what would be a good place to do that? No, I have to do it here. Sorry. Do I have to do it? This is the place. This is the place. Yeah. Oh, the thing has a reference to a plot. Hmm. Well, maybe that means that I have to make it a pointer then. No, I just implement an assignment operator, I think. There's no reason to touch the plot. I think I can't make a copy of any of these things. Let's hack that here. Show a skill. Reference. Operator, assign it. Assign another scale. As if I return, as if I use the return value. But that's how that has to be done, theoretically. So if I assign from the scale, then I want to set this scale equal to that one. And I want to set his sample equal to his sample, that one. And yeah, only if we have a sample, it makes sense to do this. But. Yeah, I should reset all of them. Did I not already do that with this? I vaguely remember that. Nope, I did not. Really not? Also not with this one? Those are not even used. Very temporary. Okay, plot connector. This is in draw. Is that what I wanted? Connector. Okay, we know. This is plot connector. It's public. Destroy. Plot indicator. That erases those plotted objects. Yeah, I just have to erase everything. So. Erase everything. Throw up is a private member, that's new, of text. No. So how is someone supposed to reset this then? Huh? Let's see how many other draw objects I have that are private. Oh boy, everything is suddenly private. This one is public. Budget curve. This one is public. Budget fitter. Private for circle. Public for connector. Nobody could up. I couldn't make up my mind apparently. I guess that for this specific case, I'm gonna go for a new member function, because who needs access to draw object, really? Let's call it reset. Not sure. We want to make this const. Let's try to do this without const. And then we go call reset here on the text object itself. And then that thing is a plot line, which is down here, and then it's public. So yeah, well, might as well, I don't know, leave it like that, or shall we add a reset here as well? Object.reset. So then I can call reset here on these two as well. Yeah, BJ Fitter was also public, but now I'm making everything reset. BJ Fitter. Plot behavior public void reset draw object plot reset. And the last one was the connector. Even though that was also public apparently. It wants me to copy this. Right click all grab sources for that reset, and then figure out that we have stuff here. Curve. What are those things? Probably BG fitters, right? I think so. Let's just try to remove them all. private member. I just typed it in here because it was closest to the existing members. And now we have to move it somewhere, like there or something. To a public key part of the class. Yeah, that does not make sense to do this because now what happens? Nothing. I removed assert and I didn't finish the code yet. And I did remove the fix me, so that now we cannot find back where we were. Alright. Let's see. Gradient descent. Where was I? Something with a board. Boards. So on the bottom of board. Yeah, this is where I was. Yeah. Restore the scale of this minimum. Okay, done. The new step size is what? Learning rate times scale. Ta-da. Low learning rate, and that's the constant one, so 0.1, a tenth of the current scale. Well, scale that belongs to that minimum. And then W delta could theoretically be set to the absolute value of that step, but this probably, I don't know, maybe. Okay, I have just no clue what W delta is being used for. Start at 0, we print it, yay. It determines the direction that we go into. And again and again and again. And here it is set to the step size that we just made. Last step size. I'm gonna copy this, I think. It looks important. Test. Seriously? So it's never assigned except here. It's just set one single time. And then only the sign is being used after that. Jesus, it's just a horizontal direction. Why do I even store this actual size of it? So confusing. Useless and confusing. Not sure that this compiles. It doesn't. Well, obviously it doesn't. This is an iterator. Let's try this one then. Yeah, okay. Let's not store step. But this would change my maximum. This would change that. I don't want that. I just want to do this, really. I'm wondering if I maybe want to change that also. Probably kind of want to reset this one as well to the value of the best minimum. Could construct a completely new kinetic energy object maybe and assign that. So I have this. I don't have to pass plot again and everything. Nah, just assign it or set or something like that. Set new values. Yes. Is that true? Equals set on the kinetic energy. Instead of doing this. New simple. Wrong key. Let's call this energy and get it from the best minimum again. Energy. Now we have to store the energy as well in the best minimum thing, which is called sample minimum. Now need to have an accessible energy, which is a double. I probably want to just set it here as well then. Energy. And then we have to pass that to the constructor. Which was here. And what is the energy then at this point? Well, we definitely blah 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 blah. I was going to say we definitely have kinetic energy. Maybe I should not call it kinetic energy because it contains the complete energy. I'm gonna pass energy. And then rename kinetic energy to energy. Which makes you doubt the whole name, kinetic energy class, but okay. Let's begin with this one. And it must automatically convert to a double, otherwise this won't work, or I have to construct it from the kinetic energy. Either will work for me. Kinetic energy. Maybe update, no. Can I even get to the energy at the moment? It's max LW, right? I can get it by, no I cannot. It's private, this thing. And it returns the current max. Yeah. Sorry, no, I need an accessor. Like, well, let's call it energy. Double energy const return max LW. It's all very confusing. I mean, it's not really to me, but I'm mixing all those units, like calling it height, and then I call it energy, and then I mix up kinetic energy and total energy, and it works, but maybe I could have, you know, used different words here and there for variable names and or comments. That's a bit dubious sometimes. Anyway, now I can get max LW, which is sometimes called energy, by calling the method energy on kinetic energy, which is storing the total energy and the current height instead of kinetic energy. I could say, well, I call it kinetic energy because this one minus that one is the kinetic energy. But it's only part of it then, isn't it? Totally. Therefore, ignoring all that, I have no idea where we came from. No. Okay, I was here, yeah. Right. So I have energy, which is the kinetic energy, and then on that I have to call, seriously, energy? Energy. Okay, now this is a clear red flag about naming. It's just, that's horrible. My naming is really off here. I'm getting also really lazy. It is all good now, but in a few weeks, when I look at this code again, and I cannot remember anything about my thoughts about that I have now, so it's just like someone else wrote it. I'm probably going to curse myself for having this kind of names. So now what happens? We go up until we are bored. That would be now, I think. No, now, yep, and I jump back to 11. It's back to the vertex and makes a step. I think 11 is like there. And my energy is back at set 47. So the energy was like 28, down to this value. I can also see it happening here, of course. The energy is now up 47. do it again. Have a good look at the energy. Energy is here. Energy goes down, 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 down. Well, it's as long as you call that down. It's now here, dude. That's hardly down, but okay. And then I press space again, and boing, it goes up. So it was reset to whatever it was when we were here. Or was it? Oh shit, really? So at the moment I stored this minimum, the energy was there. I don't think so. No. Doesn't really matter, I guess. It's all very fuzzy code is. Fuzzy like hell. As long as it's more or less doing, you know, the end here, or 10 times up, or halfway, it doesn't really matter. Bleep. Yes, 3.12 at minus 7.80. Oh, here, yeah, we are here. So now we go in this direction to accelerating. Oh, what happened? 0.15 minus 8. It jumped back. Why? Rejected. Okay, that went a bit fast. Did I reject it because... Oh, well, I went to try to go to 78. Why? So we're at 66 and then to 78. Okay, I think my program interpreted the word accelerate a little bit over the top there. Well, it's definitely accelerating. It's at 300, then 3.05, so that's almost nothing. 3.37, that's like plus 7 times more. And then it goes to 6.66. Which, I mean, if you compare that to the 0.35, that's again like it takes like it multiplies stuff by 10. So yes, that's what. Oh, okay. That yeah, it's accelerating like crazy, and I don't know why. I think my real learning rate was just insanely high and I never reset it. Where is the learning rate? Learning rate. Oh, learning rate here. No, it's not that high. Well, it's 50 times higher than the original. That is part of the acceleration. It's kind of large already. I think I should have reset it when jumping back to the minimum. Yeah, see, it should be something like 1/10. And then we increase it. And then it reaches 0.9. And then I jump back to the minimum, and then I did not reset. So all this acceleration done here is still here. So that's why it goes that fast. It's like, hey, I'm looking for a maximum and I can't find it. Let's go faster. I still can't find it. Let's go faster. Still can't find it. Let's go faster. Oh, I don't have enough energy. Okay, let's jump to the minimum. And then still with the same speed. That's not good. So I have to reset the learning rates. Accelerate, accelerate. No more energy. Go back to the minimum. Go to in the other direction. And this time it's going so slow that it's ridiculous. But oh, what really? It's already jumping back. So yeah. But what's the value that it wanted to go to now? 47? No. 59. That's ridiculous. So we do like data point, data point, data point, data point, 2021, boing, somewhere. Why? How? Arg. Not good. I don't like this at all. It's still going way too fast suddenly. How is that possible, man? How is that possible? I think it should go basically here and a little bit further. This would be a good spot. Okay, so the learning rate is now reset from 1.3 back to 0.14 or 0.1 and then already multiplied by the square root of 2, more or less, 1.4. And then again, and again, and again, and again, and again. And it's getting bigger and bigger and bigger. And bigger. It's getting quite big, I have to admit that. I think I should take the whole scale step actually, not a learning rate step. So the idea of scale is that it's just a parabola. Within the scale, it's a parabola, period. Why would I take small steps? I know there's a minimum here, and all the way up till here, it is a parabola. Therefore, start trying from here and up. Actually, I think I should set my learning rate such that it will take we are wasting a lot of time starting here because it's going uphill. It doesn't know what to do, so it's doing the normal thing except up instead of down. being a learning rate times derivative. And the derivative here is 0. So we add almost nothing. Hell, we're adding literally nothing starting here. It's that I did take a tiny step in the beginning, and then we start doing learning rate times derivative, which is still almost nothing. And then only when we finally start to escape this horizontal plateau here, it's accelerating, even just because the derivative is now positive. But I still take the history of the many steps. Each time the learning rate was increased with me. So it blows up and then goes really fast. Now if my first step is just at scale already, then the acceleration makes more sense. I mean, the 1.4 acceleration makes more sense, I think. It's all so fuzzy that there's probably plenty of possibilities, input possibilities where everything breaks down, unfortunately. Yeah, got to do something. Okay, so now we're going back to the minimum and then did a step in the opposite direction equal to the scale. Which if you look at the whole picture, this makes totally sense. And then the next step is really tiny because it's now unknown territory. Learning scale was reset to 1/10, which belongs to the tiny step. But that's boring, so we start to make larger and larger steps, just like we did here. But at least now it doesn't blow up as fast. I thought we were at 18 already, and I don't know. It's like I'm missing 19. Oh, 19 is minus 10 point. Here's 19. What? Why? So we are here and then we jump back there. That looks like it's looking for a minimum. No, what's happening? Oh, I think it jumped back. Oh, it jumped back again. Okay, yep. It's going to keep doing this, of course. There's no termination yet, so it just keeps doing this. And we reset energy as well every time. So I guess that after this point here, the next step is again all the way over the energy point. I think that's just too much of an acceleration. Maybe I should not. I mean, from here to there, where does it want to go to? Um, update 19. No, that was the last time. Okay, the one after 19 is this. 64. That's a bit fast, you know. Going from 19 to 64, why? Well, maybe I shouldn't look at the height actually. I just should look at the horizontal distance. So 64 is somewhere here, so we make these kinds of steps. Yeah, it's just I make this step and then 1.4 times more or something like that. But the slope also, it's very steep here, so we'll go faster. Yeah, I think I'm getting it. So if we go down, then we multiply it with the derivative, because we're kind of assuming in that case that if it is a straight line and the minimum is... Nah, not really. But anyway, we would say taking certain steps, and then if the derivative gets halved, then the steps that we take are half that size. So it goes slower and slower and slower and slower and slower, and you never get in the minimum. I mean, that's the normal way the gradient descent works. And that's why I'm multiplying with the derivative. And I think that you can compare that with going uphill. If you draw this horizontal line of the energy, if you draw that at the bottom here, which is then the minimum. So the closer we get to that limit, the slower we go. And multiplying the step with the derivative while going uphill doesn't seem to make much sense, does it? At least not until we actually have a minimum. Maximum, I mean. So once there is a maximum, then it would make sense. But then I use my own algorithm. Not this algorithm. So this algorithm is kind of borrowed from another method, from the plain old gradient descent, except I'm not even descending, I'm going upwards. I think the whole multiplying with the derivative is bullshit. I have to drop that. Another thing is that if I find my next point and it turns out to be still a parabola, then I should increase my scale if we go beyond the scale. So by the time you reach 135, this point here, then the scale, it's just, you know, it's all that time is this parabola with the minimum here. So then this is the scale, really. And only when we get here, then the new plot is this one, so that the scale is from here to there. So it's a little bit less because the minimum also shifted. I think it's theoretically you could say, well, I just want to step the scale every time. But it's also reasonable to more or less slow down maybe if we get to the maximum energy. So at least we try something once in the neighborhood of it without having a terrible overshoot and then rejecting it. Shouldn't do that too often, because if you get near enough, it makes no sense whatsoever to sample this point and then sample that point and then that point and then that point and then infinitely amounts of points. No. But after rejection, maybe at least once, I could use this as a limit and then to have a slowdown that causes us to come in the neighborhood of the top energy. And then give up. Okay, so I need several things. One of the things that I need is the scale must be updated. Maybe I should start with that. Man, that's an amazing amount of work. It's an amazing amount of work. I mean, there's still a lot to do. I can't hardly decide which I shall do first. Let's make a remark in the code about the insight that multiplying with the gradient is no longer very valid. And then I'll work on the increasing the scale, which is also not super trivial what to do there exactly. I think this is the only place where that does happen. Switch from the top. So here it is a remark that we will do that. That might be need to be changed as well then. And here I'm abusing the learning rate, assuming that we're going to do that. So that definitely has to change then as well. That's why this should never be done like this. I should not change the learning rate. I should just say, damn, I want my the next step to be that big. And this isn't, yeah, it just doesn't work right. Accelerating by increasing the learning rate. And here there's the same abuse again. That here then it happens. So we have to change that. Printing about it. Resetting it. Acceleration, nobody knows how to write that. Acceleration, maybe like that. Yep, well, that was it. Okay, I'm going to look into increasing the scale if I'm going uphill or downhill, but there's no minimum to just the keep going thing. That is also the keep going thing though. So here, so I'm going, and where you see either up or down, and then at this point I just need to update my scale, possibly, which I'm not doing yet. What about a random step? I think the random step is outside the scope of any parabolic approximation. Our board is the thing of its own. It's more like a complete reset of everything, and then after that we don't have any code left. So yep, I could, in this scope at the bottom here, after we made the change, do a detection if the scale has to be increased. And it can be increased only, it should be increased only actually now after, well, well, if you go away from a minimum, which is also not always the case. I'm not even sure if the parabolic approximation is valid at all in this case. When would it be? Wait a minute, my throat is hurting exactly at the spot where also the vomit reflex sits. It's hard to ignore because if I ignore it, I feel like throwing up. To drink some tea. Oh, some bottlings. You know what? I'm going to stop streaming and then buy some honey. Just gonna put honey in my tea. That worked last time. This is a thing without an end anyway. So yeah, time for